Hello everyone, I am Zhang Yifei from Inner Mongolia Normal University. I am here to present this paper. The title of the paper is Enhancing Confusing Charge Prediction with Criminal Charge Definition. This first starts with the single example about charge prediction. The image includes a factual description from a judicial document concerning a criminal case based on the definite actions and the resulting consequences. The definite is sentenced to 1 year and 6 months for violating Article 133 of the Criminal Law of the People's Republic of China for the crime of causing a traffic accident. However, charges such as the traffic accidents and dangerous driving, robbery, and extortion. We illustrate an example of such confusing charges in the graph, where blue-shaded areas represent similar elements in the two cases, whereas red-shaded areas highlight distinguishing features. In the current research of charge prediction, there are several challenges as follows. First, it is difficult to distinguish confusing charges effectively. Existing charge prediction methods have not fully leveraged specialized information within the legal domain, which results in their inability and ineffectively predict confusing charges. Second, there is a lack of sufficient external information as a supplement. For instance, criminal charge definitions and regulations promulgated by state origin. This makes it difficult to identify and predict confusing charges accurately. To enhance the charge prediction accuracy, scholars have proposed a large number of methods, which can be classified into three categories. Traditional statistical methods, machine learning methods, and deep learning methods. Due to lack of annotated data, the earliest charge prediction approaches primarily employed statistical learning methods such as the quantitative analysis and association analysis. As artificial intelligence advances, there is a growing trend among researchers to utilize machine learning methods for charge prediction. With hardware capabilities progressing and technology maturing, deep learning has achieved significant breakthroughs in fields such as computer vision and natural language processing. Consequently, scholars use deep learning for intelligent justice to assist judges in rendering decisions. Knowledge enhancement improves the understanding capabilities of artificial intelligence systems by integrating and leveraging external knowledge and expertise of specialized fields. It is widely applied in many areas such as the medical diagnosis, legal consultation, and finance services. The above related work is summarized that deep learning methods are able to capture deep semantic knowledge from judgment documents, and the knowledge enhancement adds additional information to improve model performance. Existing approaches mainly use the factual descriptions provided in the dataset to guide this task. What strategies can we use to integrate the crime definition information into the crime prediction to improve the accuracy of the prediction? So we adopt the specialized charge definition promulgated by the state as external supplementary knowledge. In the graph, we display the definition of international homicide. These charge definitions are updating through web. This graph provides an architecture for our proposed model, named the charge prediction sequence graph with the external knowledge. Traditional methods primarily extract key elements and subgraphs from limited case factual descriptions. Our model, by interacting with the vector representation of case facts, it captures the unique characteristics of each case. This integration of external knowledge transcends the formatted case facts, enabling the model to learn from a broader range of information and context. This section is divided into two main parts. First, we introduce the explanatory process of the foundation model, the crime behavior knowledge graph, and the steps involved in constructing the charge prediction knowledge graph. Construction of crime behavior knowledge graph parts defines 11 kinds of legal case relationships and 19 types of legal case entities to construct criminal proceedings to legal cases and distinguish confusing charges. It includes entities such as cause of crime, behaviors, tools, injury classifications, and accusations, as well as relationships such as use, cause, benefit, consequence, cost, and compensation. The paper proposed the construction of triples using the principle of proximity association and utilize tools for the reasonable of the data, ultimately constructing a criminal behavior sequence graph. Extraction model captures the sequential information on criminal behaviors, which reflects the order of definitions activities. This module extracts the case subgraphs and the key elements from legal case descriptions and the crime behavior knowledge graph. Encoder part implements the encoding of text information. Text CNN is used to encode factual description and key elements of legal cases. It captures rich text features and provides fine-tuned semantic information. Subgraph encode model uses a graph attention network is applied to encode case subgraph. Nodes are assigned different weight. This step captures the aggregate semantic information of neighboring nodes in the graph. And then we employed an interaction model to further address issues related to confusing charts. Experimental comparisons between different encoders in this paper show that bidirectionally gated recurrent units outperforms the bidirectional long short-term memory. Finally, we employed an attention museum to interact a criminal charge definition with the vector of case fact, thereby enhancing the representation of cases. The obtained representation information is concentrated and feed them into the softmax layer for charge prediction. We utilize the public dataset for charge prediction related by the challenge of AI in law, a competition designed to promote the application of artificial intelligence such as the NLP and information retrieval in the legal domain. For our study, we select cases involving charges of intentional injury, dangerous driving, intentional homicide, theft, robbery, extortion, fraud, and traffic accidents from the CAIO small dataset, and extract factual descriptions of legal cases using regular expression. We remove cases with missing or invalid information and retain single-person, single-charge cases to form the confusing charts with 8 charts dataset. The table provides statistics for the dataset, which contains 159,111 cases. This table reveals the data imbalance among the different charts in the dataset. The charts on the left and right side of the table are confusing charts. Similar to previous work, we consider the distribution of categories and their quantity in our dataset. From this table, it is apparent that using deep learning methods enhances the prediction accuracy substantially. Furthermore, the bi-directional gated recurrent unit main model outperforms the bi-directional long short-term memory model in terms of predicting performance and has fewer parameters, resulting in faster execution. Text-CNN is effective in capturing local factors in text and performs well in legal documents. Top charge is sensitive to imbalanced data, which affects its prediction of performance negatively. In neural charge, the graph decomposition operation is influenced by the amount of data. Our model can elevate the problems of imbalanced data, and it performs better than other models after integrating criminal charge definition, with an increase of approximately 0.73% in the micro F1 score. We conduct extensive experiments to assess the effectiveness of introducing crime charge definitions. We combine the criminal charge definition to elevate the model's performance. This achieves the goal of conducting ablation experiments to demonstrate the improved performance of charge prediction by incorporating criminal charge definitions. We conduct 8 application studies. We proposed a charge prediction model that combines knowledge graph and integrates external knowledge of criminal charge definitions and confirm that the introduction of criminal charge definitions as external knowledge can enhance model performance. This is the introduction of the paper. Thank you for your listening.